The cybersecurity industry is stuck in a completely fatal pattern right now. We build all our security boundaries around verifying exactly who is calling, but we completely fail to restrict what is actually handed over once they get inside. We're essentially treating authentication as the finish line and totally ignoring the massive payload of power that follows. This is an urgent brief, so we're going to dive straight into the data.
Look, this critical blind spot isn't just some theoretical exercise. In July 2026, it led directly to 6 major security incidents in a single month. 6 completely different attacks hitting different layers of the enterprise stack, where attackers essentially bypassed the who entirely to exploit real, standing credentials. That month was a massive wake-up call, proving that while each incident looked different on the surface, they literally all shared the exact same structural vulnerability.
And this captures the exact problem. We're successfully locking the front door, right? Our authentication layers are getting really good. But we are habitually leaving the master keys right under the doormat on the inside. Which, is great for a dog walker, but absolutely terrible when any compromised tool, malicious plugin, or manipulated AI agent can simply pick them up. We build better locks, but we just completely ignore the keys.
Section 1. Threat Intelligence. Jade Puffer, the 31-second automated ransomware.
So disclosed by Sysdig, Jade Puffer was the first documented case of ransomware run entirely by an AI agent. No human operator involved at all. Here's exactly how it went down. It entered through a Langflow vulnerability that had actually been patched over a year prior. Once inside, it didn't use some super complex zero-day. It just autonomously found standing credentials we left reachable. A default Minio login, a forged token against a default signing key, and a root database account to encrypt over 1,000 configurations. It just picked up the keys we left lying around.
But here is the truly terrifying part: the speed. At one point during the intrusion, an exploit step actually failed. But the AI agent diagnosed its own failure and self-corrected the error in just 31 seconds. Let that sink in for a second. No human reviewed a log, no human typed a new command, 31 seconds. If you're relying on human speed detection and response, this absolutely proves it is entirely obsolete.
Looking closely at this incident, independent CISO Shane Barney really hit the nail on the head. He pointed out it wasn't the AI's sophistication that caused the breach, it was the structural failure of leaving unscoped credentials in accessible environments. The real failure was that real, standing, full-scope credentials existed in places an agent, or anyone else really, could just reach out and grab.
Section 2. Threat Intelligence. Get Lost. The public GitHub issue.
Disclosed by Noma Security, Get Lost was a prompt injection flaw in GitHub's agentic workflows. And what's crazy here is that this required absolutely no stolen passwords or bypassed authentication to work. An attacker simply opened a fake, ordinary-looking issue in a public repository to manipulate a credentialed workflow agent. Because that agent held read access across the organization's entire infrastructure, it quietly pulled a private repository's contents directly into a public comment. The agent was already fully credentialed, so the attacker just told it what to do.
Section 3. Threat Intelligence. Ghost Commit. The malicious PNG image.
Discovered by researchers at the University of Missouri, Kansas City, Ghost Commit successfully hid prompt injections inside something as innocent as a simple PNG image. Why an image? Because most AI code reviewers completely ignore image files. So the hidden instructions sailed right through review. When agents like Cursor processed the file, the image manipulated them into silently reading the repository's environment secrets and encoding them as innocent-looking numbers. It's kind of fascinating, actually. Across 11 tests, Anthropic's Claude code flat-out refused to do this, but Cursor leaked the secrets completely, even when running the exact same underlying model weights.
When we zoom out and map these 3 distinct threat patterns side by side, the singular structural flaw just screams at you. Whether it's an autonomous ransomware agent, a public issue injection, or a malicious PNG image, every single incident depended entirely on a real, usable credential sitting somewhere the attack could reach.
So the crucial takeaway for your own stack is this: the primary issue isn't really how the attackers got in. The prompt injection, the unpatched server, the fake issue, those are just delivery mechanisms. The core problem is that we give our tools and agents real standing credentials before the work even begins. We're literally making those master keys the prize. Take away the prize and the whole attack chain breaks.
Section 4. The upstream design fix, devfortress, and bounding the blast radius. The necessary fix absolutely has to happen upstream, right at the design layer. We have to remove the prize entirely before the agent ever even runs.
And this is the exact mission of DevFortress. DevFortress guarantees clear, public outcomes structurally. First, upstream scope enforcement, defining exactly what an agent is permitted to invoke. Second, sub-2-second automated containment for any anomalies. And third, alias indirection, meaning the credential in the developer or agent's execution context is not the real full-scope key, but a strictly scoped alias. By ensuring that session artifacts only resolve to real access at the precise moment of authorized use, right at the execution boundary, the blast radius of any compromised agent or tool is automatically bounded. If a prompt injection successfully extracts an artifact from an agent, it just extracts an alias that has absolutely no power outside of its strictly authorized, bounded context.
And remember the speed of these attacks we talked about? Because an AI ransomware agent like Jade Puffer can self-correct a failed exploit in 31 seconds, human speed detection, waiting minutes or hours, is just totally useless. DevFortress isolates unauthorized scope deviations and triggers automated containment in under 2 seconds. It completely closes that critical time gap that autonomous agents exploit.
You can stop letting your credentials be the prize. You can bound the blast radius before the attack even starts. I highly recommend grabbing the DevFortress Master Edition textbook to learn exactly how to secure the design layer. We have got to stop relying solely on governance and detection after the fact and fix the architecture before the fact.
So as you review your own architecture, your CI/CD pipelines, and your AI agent deployments, ask yourself this final question. Are you still just checking who's at the door, or are you ready to fix the upstream credential question that nobody else is answering? Did those credentials need to be real, standing, and reachable in the first place? Take a hard look at your environments, guys, because right now, the keys are still under the mat.